You ever pick up a rock and just think, well, it's a rock? Kind of boring, right? But what if I told you that every single stone, every pebble, every boulder out there is actually a time capsule? That it holds this dramatic story of fire and pressure and incredible change? Today, we're going to learn how to read those stories and unlock the secret history of our own planet. And this quote right here, this is the key to the whole thing. See, rocks aren't just objects. They are the final products of these mind-blowing geological processes. Think of them like the last page of a chapter in Earth's autobiography. To really understand the rock, you have to understand the journey it took. And the plot for all of these epic stories? That's what geologists call the rock cycle. It's basically a planetary-scale recycling program that's been running for billions of years. So let's follow a rock through its potential lives, starting at the very, very beginning, its fiery birth deep inside the Earth. Okay, so our story begins in a place of just unimaginable heat and pressure, a place where solid rock can actually melt and start its journey upwards. This is the birthplace of all igneous rocks. First things first, we need to get a crucial distinction straight. When molten rock is still underground, we call it magma. And it's full of all these dissolved gases, kind of like a shaken-up can of soda. But once it erupts onto the surface, now it's called lava. Most of those gases have fizzled out into the atmosphere. It's the same stuff, but location is absolutely everything. Now you might think, okay, melting a rock, you just turn up the heat, right? But it's actually way more clever than that. You can melt solid rock by simply decreasing the pressure on it. That's called decompression melting. Or, and this is wild, you can add water, which lowers the rock's melting point. It's like a surprisingly complex recipe. So once we have that molten rock, it can cool down and become solid in one of two places. And this creates two totally distinct families of igneous rock. If it freezes really slowly, deep underground, we call it intrusive. If it freezes super quickly up on the surface, it's extrusive. And this one little difference, where it cools, changes everything about the rock it becomes. Think about it. When magma is trapped deep underground, it's insulated. It cools down incredibly slowly. We're talking thousands, maybe millions of years. This gives the atoms all the time in the world to find each other and arrange themselves into these big, beautiful interlocking crystals that you can easily see. The speckles in a granite countertop, that's a perfect example, a classic intrusive rock. But when lava hits the cool surface, it's a frantic race against time. It cools in just minutes or hours, so the atoms have practically no time to form big crystals. This gives you a really fine-grained rock, like basalt. Or, if it cools almost instantly, it becomes volcanic glass, like obsidian, with no crystals at all. Now for the next chapter. Once our igneous rock is exposed on the surface, it gets battered by wind, rain, and ice. The forces of nature just start tearing it apart, creating the raw materials for a completely new kind of rock. This kicks off the great journey of a sediment. Tiny fragments of that parent rock get broken off. That's called weathering. From there, they get carried away by rivers or wind or glaciers, and eventually they get dropped off or deposited, usually at the bottom of a lake or an ocean, where they settle in these really distinct layers. But how does a loose pile of sand become solid sandstone? Well, it's a two-step process we call lithification. First, you get compaction. The immense weight of all the new layers piling on top squeezes all the water and air out. Then, you get cementation. Water carrying dissolved minerals trickles through the gaps, and those minerals act like a natural glue, cementing all the grains together.
Okay, this is where it gets really cool. Because of how they form, layer by painstaking layer, sedimentary rocks are basically history books. They trap clues about what the surface of the Earth was like millions of years ago. So, how do we read them?
It's all about playing detective and reading the clues. For instance, if you see ripple marks perfectly preserved in the rock, you know there was flowing water, like a river or waves on a beach. Find some mud cracks, that tells you it was a wet, muddy place that dried out in the sun. And of course, the most famous clues of all are fossils, the actual evidence of ancient life trapped between the layers.
We can even group these rocks into three main classes, and it all depends on their origin story. You've got clastic rocks, which are made from physical bits and pieces of other rocks. Then there are chemical rocks, which form when minerals crystallize directly out of water, like rock salt from an evaporating sea. And finally, organic rocks, which are made from the compressed remains of living things, like coal from ancient swamps.
All right, on to our third and final act. What happens if our rock, say our sedimentary rock, gets buried deep within the Earth all over again? This time, it doesn't melt. Not yet, anyway. Instead, it gets subjected to intense heat and pressure that are going to fundamentally transform it. This process is called metamorphism, which literally means to change form. The best way to think about it is like baking a cake. You take flour, eggs, sugar, and with heat, you transform them into something completely new. The ingredients are the same, but the final product is totally different. It's the same for a rock. It changes, it recrystallizes, all while staying in a solid state. So to really see this in action, let's follow the journey of a really common sedimentary rock called shale, which is pretty much just hardened mud, as it goes through more and more intense metamorphism. With just a little bit of heat and pressure, what we'd call low-grade metamorphism, the tiny clay minerals inside that shale start to align themselves, and it turns into slate. That alignment is exactly why slate splits so perfectly into those thin, flat sheets. It's why we use it for things like roof tiles. Okay, now let's turn up the heat and pressure even more. New minerals actually start to grow. Those tiny clay particles recrystallize into larger, shiny mica crystals. Our rock is now a schist, and you can actually see that sparkle with your own eyes. At really high-grade conditions, things get extreme. The minerals actually start to segregate from each other, organizing themselves into bands of light and dark colors. This creates a brand new rock called gneiss. That distinctive banding tells a geologist that this rock has been through some serious heat and pressure. Now this banding that we see in gneiss, or the sheet-like layers in slate, that's a texture called foliation. It's caused by pressure that's stronger in one direction than the others. It literally squishes the rock and aligns the minerals. But if a rock like limestone is just baked by heat, without that directional squishing, it becomes non-foliated marble. Just a mass of interlocking crystals with no alignment at all. So, we've seen our three main characters in this global story: igneous, sedimentary, and metamorphic rocks. But now it's time to see how they're all connected in one continuous, magnificent loop. This is the ultimate takeaway, the big idea. The rock cycle means that no rock is forever. Any rock type can become any other rock type. An igneous granite can get eroded into sand and become a sedimentary sandstone. That sandstone can get buried and transformed into a metamorphic quartzite. And that quartzite can get pushed down even deeper until it melts into magma and cools into a whole new igneous rock. It is a never-ending cycle of creation, destruction, and transformation. So the next time you see a mountain or a stone in a field or even the countertop in your kitchen, remember, it's not just a rock. It's a snapshot from a story that's billions of years old. And it kind of makes you wonder, what chapter of that story is being written right now, right under your feet?